Mike Dudley here from the Virginia Asphalt Association, and in this presentation we're going to cover a quick review of the things that have been the main things that were covered in the Asphalt Plant Level 2 class. We're going to be talking about some asphalt mix components, whether it be the aggregate or the binder, the main components of the asphalt mixture. We're going to talk about some of the primary duties of the Asphalt Plant Level 2 technician, which is why you're taking this class to get the certification. We'll also cover some volumetric testing. Let's start with the asphalt mix components. The asphalt binder is, as we mentioned earlier, is about 4 to 6% of the mix by weight, or 10 to 12% of the mixture by volume, depending on if you're looking at it by weight or by volume. The asphalt binder is what binds the aggregate particles together. It's basically the glue that holds everything together and gives it strength. The binder is the primary element that affects the cracking and rutting resistance. And the binder can have different additives and polymers in it that will improve this cracking and rutting resistance. We always have to remember that some of our binder may have came from the wrapper RAS, which could be oxidized, it could be a little stiffer binder, but during the mixing process, some of this, not all of it, but some of it will blend with the virgin binder to affect the final mixture. Another component of the asphalt mixture itself is the aggregates. Again, by weight, you're looking at 94 to 96%. Notice here we got, by weight, we're looking, our percentages between binder and aggregate will total 100. Whereas by volume, we're looking at only 75 to 85% by volume for the aggregate. And if you add that to the volume of the binder, it doesn't equal 100. Guess why? Because we have air, we have voids that are actually part of the volume that would not impact the weight. So I like to point that out. When it comes to aggregates, we divide them into two categories. The fine aggregate is basically the -4 material. Anything that passes the 4 sieve is considered a fine aggregate. The coarse aggregate is the +4 material. Anything retained on the 4, 3/8, ½ inch, and so on sieve. Again, when we're dealing with a recycled product like wrapper RAS, we do get aggregate from those materials. Some people call it black rock, but the binder does do some impact the performance of the mix. Let's talk a little bit more in detail about the binder system. All our binders are classified as a PG64, which is our standard grade binder, -22. And then when we classify them, we have a letter acronym that gives us different references. The X you see in this PowerPoint here could be anything starting with S. S is our softest binder, which basically is our rural routes, some subdivisions, some pavements that aren't going to have very high truck traffic. H for harder, H for the word harder, is slightly harder than the S. Those of you who've been doing this for a while would have been our old PG system, would have been a PG70 instead of a PG64. But the H will have a little bit more truck traffic, and as we continuously progress in heavier loads and heavier truck traffic, we go to V. Okay, the V is for very hard binder, which is for higher truck loads than the other two. And the last one we have is an E binder, which is for extreme truck traffic. You're going to see this on I-95, on I-81 in the state of Virginia. And this is going to be a much higher polymerized binder that is made for much heavier loads in trafficking. And we also can include special binders. Some of our special binders may be a rubberized binder where we've incorporated a ground tire rubber or another additive into these binders. Next, we're going to cover a couple of the physical characteristics of an asphalt mix. We're going to go through in the next slides. We're going to talk about the voids in the total mixture, voids in mineral aggregate, voids filled with asphalt, and defines the asphalt ratio. Let's start with the voids of the total mixture. Air voids in the mix. For our lab-made specimens, our air voids can range between 2 and 5% to meet spec, which we want to target more between 3 and 4%, the center of this range, at all times. For the mix in the field, our voids could be anywhere between 5 and 7.5% in the field placement to get approved mixes and to meet specification. But what happens if the air voids are too low or possibly too high? Low air voids decreases permeability, which keeps water out and helps reduce oxidation. So the tighter we can get the mix, usually the better, as long as we don't go too far. And a lot of it depends on how we're getting these voids as tight as we can. If we have too much binder in these voids, filling them up with binder, what can happen after placement is we can have some flushing, which can impact skid resistance and other things, which is bad. So we do want it as tight as we can get it, but we don't want to fill those voids with too much binder. What happens if we have high air voids? High air voids can promote rutting. If we don't get good densification of our mix when we're placing our mix, what's going to happen is once this mix is opened up to traffic, the wheels of the traffic are going to continue to compact it into wheel paths. Then we're going to end up with rutting in these wheel paths. Also, if we don't have good density, we're going to have high permeability, which would allow more water to get into the pavement, and that water, as it gets into the pavement and traffic runs over top of it, we get that capillary action as traffic passes, is going to promote stripping. What about voids in mineral aggregate, VMA? They're basically the air void spaces that exist between the aggregate particles in compacted pavement mixture with the asphalt binder removed. So if you got a specimen, let's talk about VMA as far as on a specimen, if you got all the air space and then the binder was included in that space, it's everything except for the aggregate. It's going to give you a total void range available to put your mastic in it or put your binder in it and have air void space. So the higher VMA, the more space available to increase the asphalt content, which will basically increase the durability of our mixture. VFA, voids filled with asphalt, is the percentage of voids in the compacted aggregate mass, or basically in our VMA, that are filled with asphalt binder. You got to be careful with your VFA. You can have too much of this as well. If the VFA is too low, there's not enough asphalt binder to provide durability, and basically your mix is going to be prone to fatigue, prone to raveling, prone to things that it ain't going to hold together as well. Again, if you don't have enough binder to glue everything together, it ain't going to have enough glue to hold together. So you got to make sure you got enough of that. But on the other end of this, the flip side, if the VFA is too high, then the available VMA has been overfilled with the asphalt binder, and the mix is prone to over-densification and possible rutting or other things can happen based on too much of the VFA. Fines to asphalt ratio. Fines to asphalt ratio is an indication of the asphalt binder film thickness and on the coating of the particles. Basically, it's also, I like to think of it as a mastic, the combination of the asphalt binder and the very fine aggregate material that's in this, that combines to create a mastic. And you want to have enough mastic to make sure you're getting good performance, but too much of this mastic can also create problems, as we mentioned before. It can promote rutting and other issues. So the fines to asphalt ratio is calculated using the effective asphalt binder. It's not the total binder content. We covered this in some earlier presentations. The furnace will measure a total binder content, and it gives us the total asphalt content of the mix. But when we're calculating the fines to effective ratio, we just want to use the effective binder content, which is the total binder content minus any asphalt that's absorbed into our aggregate structure. So it's always going to be a number a little bit lower than our total asphalt content that's used to calculate the fines to asphalt ratio. Some other important properties, just to give you a reminder of, you got your bulk specific gravity of your mix. Basically, that's how we're measuring the voids of our specimens, whether it can be a field core, we can talk about that, covered in the field classes, or a laboratory compacted specimen. Maximum specific gravity is the maximum gravity when all the air has been vacuumed out, and so it's the maximum specific gravity of our specimen. That becomes our reference material to calculate our actual void ranges off of. TSR, tensile strength ratio, you're talking again about a stripping test that we have to look at. This is usually done early on, and when we start up new job mix formulas, we got to make sure our TSR and our anti-strip is working. We got to remember that Virginia does require an anti-strip to be added to all our mixes, no matter what the TSR ratio is. We are required to have an anti-strip. And then the moisture content of the mix. We talked about that in earlier presentations. The specification allows up to 1% in the mix. Moisture can be in there, but no more. One thing we also referenced was be careful if you have a higher moisture content in your mix. This has been linked to possibly having tenderness. If you laid a mix one day that was very good compaction, had no issues, you had a nice heavy rain the next day or that night, so the next day's production, you fire up and all of a sudden the exact same mix you placed the day before, the guys in the field saying, what's going on? This mix is tender, it's moving under the rollers. You might want to run a quick moisture test. You can do this really quick. You might find out that your moisture is a little high in your mix, and that can impact test results, it can impact performance of the mix as it's being compacted when it's being laid and put in place. Now let's talk for a minute about asphalt plant level 2 technician, the requirements for the technician and what the certification actually means. It is a requirement by VDOT that any technician doing production testing has to have at least the asphalt plant level 2 certification. Okay? This certification is why you're attending this course and why you're taking this class, and at the end you'll be taking your exam to receive this. These asphalt plant level 2 technicians are also able to pull samples and quarter samples. Okay, they can do all the general testing that keeps a plant operational. They can measure the asphalt content, basically your furnace burn. We covered that, and do your gradation. This is done in 500-ton increments on a sublot basis. So it's done based on a random numberization table that tells you when to take these samples. They can also do the mixture volumetric testing. They can do the gyratory peels. They can run the moisture content on these samples. So with this test, these are done in basically 1,000 sublot tons, randomly picked as well. And don't forget, we have to always, this same plant level 2 technician is responsible for measuring the temperature of our mixes and making sure it stays pretty constant. You always want to test the first load, the 5th load, and then once every hour after that. The technicians are, one thing that they are not allowed to do, even though they may be doing the testing, you have to have a mix design certification to make any mix changes at the plant or to even put a plant into operation. Quick wrap up here. It's important as the asphalt plant level 2 technician to know your mix design, know what your targets are, know what your gradation band is and your target ranges you're looking for. It's important to know your sample rates. It's important to know where you get your randomized sampling numbers to make sure you're maintaining your proper sampling rates. And as we talked about before, your acceptance ranges, whether it be for your furnace burn, your binder content, or your gradation, you want to make sure that not just spec sieves stay in tolerance, but all the sieves are staying within tolerance. I think we talked about some control charts previously. These are a real great visual resource to be able to monitor your asphalt content and your gradations to make sure everything's staying constant. You don't want a whole bunch of peaks and valleys in these in your plots of these control charts. You want to know your volumetric properties, you want to know your void range, your VMA, your VFA. You want to make sure while you're doing your testing that all your samples are staying within allowable specification ranges. And it's important that we follow the QA program that's established by VDOT in our MOI and our road and bridge specifications. With that, if you have any questions, you can reach out to your proctor, and we thank you for your time.